In this video, we'll finish up section 7.4 with 4 examples. All right, so looking at this, I'm going to write down the formula from above. So cosine of alpha minus cosine of beta equals -2 sine, and then it's going to be the sum divided by 2, and then sine, and then alpha minus beta divided by 2. Okay, they want us to prove this, evaluate it. Okay, so cosine of 15 degrees minus cosine of 75 degrees. If I'm just using that formula, this is equal to -2 sine of, it says to add the two. Okay, so that's 80, 90 divided by 2 is a 45 degree. And then sine of, you got to subtract them and divide by 2. So 15, that's -60 degrees. All right, I'm going to do one thing here because I don't like that negative. Negative sign, remember that sine of a negative angle is the negative sign of the regular. So I'm just going to make it a positive up front, and then I'm going to rewrite this and make that negative a positive. That way I don't have to worry about it. All right, so we got to work these out now. So this is 2 times the sine of 45 is square root of 2 over 2. And then the sine of 60 degrees is rad 3 over 2. That's a tall triangle. So this equals rad 6 over 4. Not too bad. All right, the next one we're going to have to prove. So they want us to prove this identity. So maybe we need the sine one. So let me grab, I'm going to write down, here's my cosine formula. I'm going to write down the sine formula now too, because I got the subtraction. I need a sine alpha plus sine beta. That's what's on the bottom of that fraction there. And that's going to be 2 sine of the sums, and then cosine of the difference divided by 2. All right, so I'm going to work on the left side here. So I know the left side is going to follow the top formula I have there. That's -2 sine, and then I add them, that's 6t over 2, which is 3t. And then times sine of the difference, that's 2t over 2, which is going to be a t. All right, and then the bottom is going to be a 2 sine, and then that says to add them, so that's 6t over 2, which is a 3t. And then on the bottom is going to be a cosine of, subtract them, 4 minus 2 is 2, divided by 2 is a t. So you notice I get negative sine t over cosine t, everything else cancels, and that is a negative tan t, which is what we're trying to prove. All right, not bad. It's just a lot of these identities that come from these formulas is once you plug it into the formula, things just kind of cancel and work out for us. All right, let's do another. All right, so this one isn't totally obvious on maybe what we're gonna do. I like to, as soon as I see the square, I want to mess with it and see if I can figure that out. But let's maybe work on something else. What could we do? Okay, so I see a cosine 2 theta. And if we were to take cosine 2 theta and maybe break it into something else, maybe, hold on, my brain's running through some things here. Let's do this. Okay, I'm going to remind you guys something. Cosine 2 theta, all right, that's going to be equal to, all right, we had a couple options here. Okay, one option would be, um, cosine squared theta. Sorry, my brain blinked for a moment. Minus sine squared theta. I think that's going to be our best bet. Okay, so if I'm working this side, okay, I'm going to get cosine squared theta minus sine squared theta. That comes from our double angle formulas. We did that a couple sections ago, over sine squared theta. All right, well, this is cosine squared theta over sine squared theta minus, and then it's going to be sine squared theta over sine squared theta. All right, this is going to get me a cotangent squared theta minus 1. But that's not what we were wanting. Now, I see, okay, I'm going to move this over because I'm going to need the space here in a moment. This was just a formula, so I'm going to highlight that a different color. That's not part of my work. Okay, I see that cotangent squared. Now, this is how I go about my identities with squares. So I know that one. I need a cotangent, so I'm going to divide by sine. And divide by sine. There we go. And divide by sine. And this will tell me the formula. 1 plus cotangent squared equals, that's a secant, or a cosecant, sorry, cosecant squared. And I can see that cotangent squared is going to be cosecant squared theta minus 1. So if I were to replace that down here, then I'm going to get cosecant squared theta, and then minus 1. This is, I'm going to have minus 1 out of that. So it's going to be a minus 2, which is what I was looking for. So again, when I started this, just so you guys know, like I didn't know which route we were going to take. I just kind of I thought about changing this. I know these change anytime I have a 2 in there. So I went and looked up my formulas real quick for 2. And why I chose this one, there's 3 to choose from, is because I was really wanting to do something with that square. So that's why I introduced these. There's some others too, like 1 minus 2 sine squared or something like that, I believe, or 2 cosine squared theta minus 1, something like that. But those wouldn't have worked out as well. Actually, they may have been fine. This one probably would have worked a little faster, actually, than what I did. I typically take the longer route around. Okay, one more identity here. So I'm gonna write it down. Tangent theta, cotangent theta, minus cosine squared theta equals sine squared theta. This is just too fast. I don't even know why this one's here. Tangent times cotangent. I know those are inverses, so I get a 1 minus cosine squared theta. And hopefully you guys know that that is sine squared theta, which is that. So we're done. Not sure why that one was there, but it is. So it's a good reminder that's a classic problem. All right, give this section a try. It's just formula based. Don't memorize unless you can, but make sure that you're extremely familiar with what the formula looks like.